Okay, this is Unit 5B review. Our first problem gives us some information. We've got some constraints. Our first constraint, t plus c less than or equal to 100. So I've got a t-intercept of 120 and a c-intercept of 120. So that means that we're going to go from one point to the next. We've got, on our next problem, 8 goes into 800 100 times, so we've got a t-intercept of 100. And 4 goes into 800 200 times, so we've got a y-intercept of 200, or a c-intercept of 200. That's going down 2 over 1. Our shading, 0 is less than or equal to 120, so we'd shade the bottom, and 0 is less than or equal to 800, so we'd shade the bottom here. So that means we'd shade over here. Our vertices are going to be the point right here at 0, 120, point right here at, oops, I drew the line wrong. That should really be right here. Should be at 80, 40. And the last one should be over here at 100, 0. So then we're going to plug in those values into our objective function. So our first one, we don't need to plug in a 0 for t because it's 0. So 5 times 120, and that makes 600. Our next one would be 7 times 80 plus 5 times 40. Well, 7 times 80 would be 560, and 5 times 40 would be 200, so that makes 760. And our next one is 7 times 100 plus 5 times 0, so that's 700. So for which combination of caps and t-shirts did you find the maximum profit was 80/40? And what was that? That was 760. And the minimum profit was 120, and that was 600. Our next problem, we've got an x-intercept of 0. So that's a vertical line at 0. We're going to shade on the right side of this because we're greater than. A y-intercept at 0. We're going to shade on top. And our next one, 3 goes into 12 4 times, so our x-intercept is at 4. And 2 goes into 12 6 times, so our y-intercept is at 6. If we pick 0 0, then we'd want to shade 0 is less than 12, so we'd shade the bottom. So our feasible region is this triangle here. So we've got a constraint, or a vertice at 0 6 and at 4 0. So we're going to plug those into our objective function. So 4 times 0 plus 5 times 6 makes 30, and 4 times 4 plus 5 times 0 makes 16. So our max was at 0 6, and our min was at 4 0. Graphing, y-intercept of -3, slope of 1. We don't have the equal sign, so we're going to be a dashed line. And we're not eating the y, so we're going to shade the bottom. Our next one, y-intercept is at 4, slope is -2, down 2, right 1, up 2, left 1. We've got the equal sign, so we're going to solid line. And we're not eating, so we're going to shade the bottom. So the bottom of both those lines would be right here. Our next equation, y-intercept is at 2, slope is down 3, right 4, down 3 and right 4, up 3 and left 4, up 3 and left 4, dashed line. We're going to shade, it's eating the y, so we'd shade on top. Our next equation, y-intercept is at 0. We're going to go up 1, right 3, up 1, right 3, up 1, right 3, down 1, left 3, down 1, left 3, down 1, left 3. We've got the equal sign, so we're going to do a solid line. We're not eating the y, so we shade on bottom. So that would be this section here. Our next section, that's a vertical line at -3. We're going to be greater than, so we're going to shade the right side. Horizontal line at 5, dashed because we don't have the equal symbol, and we're less than, so we're going to shade the bottom. So we'd be here. Our next line, this isn't in slope-intercept form, and 2 doesn't go into 5, so I'm going to put this in slope-intercept form by subtracting 2x from both sides. So we get y equals -2x plus 5. Our y-intercept is 5. Our slope is -2, so we go down 2 and right 1, up 2 and left 1. I forgot. This is an inequality, so our inequality. And we're not eating the y, so we want to shade the bottom. Our next equation, -2 and -4 both go into 8, so we can leave it alone and just solve by the intercepts. So -2 goes into 8 -4 times, so our x-intercept is -4, and -4 goes into 8 -2 times, so our y-intercept is -2. That looks like we're going down 1 over 2, up 1, left 2, and we've got the equal sign, so we'll do a solid line here. And now we do our test point, is 0 less than or equal to 8? Yes, that's true, so we want to shade the top. So our feasible region in there. Our next problem, we've got constraint here, x is less than or equal to 600, that would be a vertical line at 600. We've got, oh, sorry, and I should shade less than, I'd want to shade the left. Our next one, y less than or equal to 500, well, that'll be right in between here. And we're less than or equal to, so I'd shade the bottom. And we've got another one, 10x plus 12y less than or equal to 8400. So 10 goes into 8400, that would be 840, so our x-intercept is 840. It's right out here. 12 goes into 84 7 times, so this would be 700. So that would be right there. We'll draw our lines. Oops, let's do that better than that. Looks like so. And so, what are our vertices? Looks like we've got, oh, we want to be below this line because 0 is less than or equal to 8,400. So that's true. That's true, so we want to be on the 0 side. So where would we be? Everything in here. So we've got a vertex here at 0, 500. We've got a vertex here at 200, 500. We've got a vertex here at 600, 200, and we've got a vertex here at 600, 0. And we're going to be plugging in those numbers into our objective function right here. So our first one, 0 into x, so we don't need to do that. 500, or actually 20 times 500, and that makes 12. 2 times 5 is 10, and we have 1, 2, 3 zeros, so that's 10,000. Our next one, 18 times 200 plus 20 times 500, so that would be 3,600 plus 10,000, and that would make 13,600. And our next one, 18 times 600 plus 20 times 200. 18 times 600 is 10,800, and 20 times 200 is 4,000, so this makes 14,800. And our last one, 600 and 0, so 18 times 600, we already did that, that was 10,800. So we've got a maximum at 600, 400, sorry, 600, 200, right here, our maximum. And we had a minimum of 10,000, that was at 0, 500. So our minimum is right here. Our next problem, we've got an x-intercept, 20 goes into 80,000. Well, take away my 0, take away a 0, and 2 goes into 8 4 times with 4 zeros, so that's going to be 4,000. X-intercept is 4,000. Same thing here, 10, so that would be 8,000 for my y-intercept. Draw our line, that's down 2 over 1. Our next equation, 10 goes into 60,000, well, that's going to be 6,000. And 10 goes into 60,000, that's 6,000, so that's down 1 over 1. And I forgot to do the shading, so our first one, 0 is less than or equal to 800, so this will be below the blue line. And 0 is less than or equal to 60,000, so that would be below the green line. So our feasible region is everything on the left. Looks like we're going to have a vertex, or a vertex there at 0, 6,000. Have another vertex here at 2,000, 4,000. And another vertex here at 4,000, 0. So we'll plug them into our objective function. So this one is 6 times 6,000, that makes 36,000. Next one is 10 times 2,000 plus 6 times 4,000. Well, that's 20,000 plus 24,000, which makes 44,000. And our last one is 10 times 4,000, which makes 40,000. So we've got a maximum here, and that was at 2,000, 4,000, that's right here, is our max. And we had a minimum of 36,000 and 6,000, so that was right here, was our min. This first problem's already solved for y, so we'll plug in that value into y. So we say negative 3x minus 4 times y equals negative 10. Plugging in a 4x plus 12. Distribute our negative 4, negative 3x minus 16x minus 48 equals negative 10. Combine our like terms, add 48 to both sides. 48 minus 10 makes 38. Negative 16 and negative 3 make negative 19x. Divide by negative 19, and x equals negative 2. We'll substitute that back in for x. Y equals 4 times negative 2 plus 12. Y equals negative 8 plus 12. So y equals 4. Negative 2, 4 is our solution. Our next problem, we don't have anything solved for, but I've got a negative 2x, so I'm going to multiply everything by 2, get positive 2x minus 6y equals negative 34. When I add these equations together, I get negative 11y equals negative 55. Divide by negative 11. Y equals 5. Substitute this back in anywhere. We'll use the top equation. X minus 3 times 5 equals negative 17. X minus 15 equals negative 17. Add 15 to both sides. X equals negative 2. Negative 2, 5 is our solution. Our next problem, we've got plus and minus 5y. Those are going to cancel. We've got 5x equals negative 35. Divide by 5. X equals negative 7. Substitute this back in for x. 2 times x minus 5y equals negative 4. Plugging in a negative 7. Negative 14 minus 5y equals negative 4. Add 14 to both sides. Negative 5y equals 10. Divide by negative 5. And y equals negative 2. Our solution is negative 7, negative 2. Our next one, let's multiply this top equation by 2, and we get 2x plus 4y equals negative 14. That way our y's cancel, so we have 5x equals negative 15. Divide by 5. X equals negative 3. Substitute the negative 3 in. Negative 3 plus 2y equals negative 7. Add 3. 2y equals negative 4. Divide by 2. Y equals negative 2. Our solution, negative 3, negative 2. And our last problem, the sum of two integers is 249 and their difference is 135. What are the two numbers? So we've got x plus y equals 249. Their difference is 134. So x minus y equals 135. So what can we do? Well, we can add these two equations together, right? We can take this equation here and pull cancel it over underneath because it looks like we've got opposites. Right? So our y's would cancel and we'd get 2x equals 249 and 135 equals 384. Divide by 2. So 384 divided by 2 is 192. And x equal, so that would be then, we need to subtract 135 because that's our difference. So 192 minus 135. And y must be 57. So those are my two numbers.